Hello, my name is Nathan Rini. I'm presenting containers in Slurm from SchedMD for today. All right. Please feel free to ask questions in the chat. I will be monitoring it, but I might have to defer some of the questions till later. I always ask that everyone please take a look at our containers doc. The URL is right here. It has a lot of the information. All right. So Slum has been around for a little while. In the release 2108, we got a new feature for containers, but I'm going to cover what was before that, and they still apply. So users could call containers runtimes directly in jobs. This is the classic way of doing it. Charlie Cloud does it. Singularity does it now. I mean, users just have to manage everything themselves, or the admin has to give them some kind of script that helps them manage it, and in some cases, set UID binaries or pseudo commands. Most powerful version, and it's the most painful for everyone involved because you have to manage everything. Next option is containers via Spake plugins. Slurm allows developers to write plugins that hook into key places where the user flow is, and they can intercept these things and start a container instead of a normal job. Certain limitations of Slurm limit these plugins, but there have been several of them, like Shifter, and they seem to work pretty well. They can make lives a little bit easier and allow sites to have a considerable amount of control because the Spink plugins are executed in trusted locations. So they can actually enforce site rules. And the final way of containers, very limited, but using a mount namespace, you run slurmd inside of that. So let's say you have a completely light OS install on your nodes, and then you just, for all effective purposes, chroot into somewhere like a shared file system or GPFS or something like that, and the users will see it that way. Not the best, but it is possible, and some sites have been doing it. So this is the way it was before 2108. Those are the options, really. First, I want to give a notice that this is a technical preview. We are actively working on this. Now, while it's not going to change in the 2108 release, 2205 might change, and we humbly request RFE tickets. So we're very open to hearing site input, and it would be really nice to get some. Other thing is, containers are horribly ambiguous, although I think the audience here probably knows what they are now. When I'm talking container for this specific part, I'm talking OCI containers. And here's the link to the actual definitions. And just as a note, this is completely different than the job container /tempfs plugins, which also make a namespace, but it is not specifically containers. That's for normal jobs. Although you can stack them. So it's generally not needed. All right, so for container support, Slurm has now been modified to run OCI runtime. So the user will just hand over a OCI image bundle path, and Slurm will then look at its config in the OCI.conf and actually call the OCI runtime for the user, making it as transparent as possible. The OCI containers have a good bit of history. They originally developed by the Docker group, but now they're in Kubernetes and everywhere else. Most of the container systems support them in some form of another. It's really simple standard. More or less, you just have to have a root directory and then a JSON file that tells you where everything is. As a side note, Docker tends to be out of sync with this. So the Docker that you're running will not be making OCI containers that are exact older version, because they always seem to be bleeding edge. It's sometimes not even versions of non-versioned releases of OCI standard or stuff that's pending, which hopefully for users isn't an issue. And I already know, it was already SARS that already had full OCI support because it was doing run C. Okay, so the new option or new argument is container -- container. You can give it to srun, salloc, or sbatch. And then Slurm will take that, and it's a fully honored config option, so you can see it inside showed steps, showed jobs, S account, and all the logs. If you do an S account, you just got to make sure that you pass the argument so it dumps the containers. It doesn't do it by default. And it gets saved in the Slurm database and full job accounting, everything. Okay. Right now, Slurm only executes unprivileged OCI containers, so all the existing Slurm C group features apply to them. It just gets inherited because it's running as a user. The user can't escape them anyway. So all the normal site limits can be applied, all the job things, clean up on OM events, all these things apply, and it still works. 21.8, we have no plans to do anything but unprivileged containers. RFEs are, of course, welcome. I have a hard time seeing why any site would actually need a privileged one in the near future, but I'm definitely open to input. Luckily enough, this is all thanks to new kernel features that were thrown in the kernel like 6 years ago or so, which everyone should be running now. Thing of note here is there is a new OCI.conf config file in the Slurm configuration directory. If sites don't populate this OCI.conf or it doesn't even exist, when the user passes -- container, it just gets set as an environment variable and nothing else will happen. So that if the user decides, they can use the Spank plugin or something else to intercept that and do as they please. So I'm going to give you an srun example here. In my temp directory, I just put a CentOS image. In this case, it's just 8. And I crap out the OS release, and I'm running on Ubuntu just as example. And then same with salloc, grants a job, no control in the shell. So TTYs aren't completely there yet with containers, and sometimes you can get permission denied for certain IO controls. These actually don't affect the job. It's just there is interesting. I'll have to look at it later more, but so far it seems like it's just an issue upstream. All right. And for reference, it'll dump the same thing out here if you call it. And then sbatch, same thing, -- container, and I request the OS release, and it's CentOS, and I'm running Ubuntu, so I know it's working. The whole goal here is to make it much easier for users to just point at the container they want. Now, since we're following a standard here, there's a lot of stipulations and rules, and they all come specifically from the spec. I have the link here to it. The important part is that the OCI image is visible on the executing compute node. So if the user has it on their laptop and it's not on the shared file systems, it's not going to work. It must be on shared file system or at least visible to the node. Currently, Slurm doesn't copy or mount any images directly from the job submission node. So users might get surprised by that, maybe depending on how your setup is. And then the OCI image structure is very specific about certain parts. So there must always be the config.json, and it must be filled out correctly. And then Slurm will actually read the config.json and prepare its own job-specific one so that each task in the job can run independently of another, so they don't stomp on each other. Then the OCI runtime handles all the mounting details, handling all the slicing of the images, all that. So as stated before, we are definitely requesting input from sites. This is the first step. Just want to note that Slurm is a scheduler, not a container runtime. We want to make sure as many container solutions work with Slurm as possible. We use OCI because it's very popular and it's very easy to, I haven't seen a single image type that can't be converted over to it. And if you look at the OCI.conf file for administrators, it is pattern based, so you can do substitution of key variables and make a command that you need. So the OCI standard provides general operations, but it's not very strict. So the actual command arguments are variable between different OCI runtimes. So this gives you the ability for the site admin to decide what they want there, and they can modify it as they please. Another side note is if a site does want their images pushed around, the new Lua Burst Buffer plugin can be used to do this. Because it just allows asynchronous execution. Currently, there's no integration with the container part, but looking to see if sites are interested in that. Okay, I haven't seen any questions in the chat yet, so I'm just going to keep going. So, your organizers gave me a few questions to answer beforehand, so I'm just going to run through them. Will there be support of non-OCI rootless runtimes such as Singularity in native container support of Slurm? Not plugin, or should you just wait for rootless implementation of Singularity or Apptainer? So Singularity actually already supports rootless in the sandbox mode, and ironically, that doesn't support rootless with Singularity OCI support. I'm hoping that they're going to fix this soon because I don't see any reason why they're not. But here's an example of actually how to configure Singularity into the system. In general, I don't suggest this for shared HPC sites because you got to call sudo. This is a specific limitation of Singularity. Other ones don't seem to have this. But that's how you can set it up. This is an example of the patterns. In this case, I just make sure the names are unique by putting in all the info we have, along with the OCI command for Singularity. And it's all split off to this OCI subcommand. I would expect that people running in cloud or one user host is, security is not the issue here. But for shared systems, another system might be advised, like Charlie Cloud. So what are the benefits of running OCI containers with built-in native support in comparison to running job and invoking a container runtime within the job script? So the idea is to make it easier for the users. Start making this a lot more seamless for everyone involved. Admins give them the control that they need. Users, they just want to run their jobs. They don't really care about learning all the minutiae of details of container theory and container image requirements and stuff like that. Just want it to work. So the hope is that a large number of these container developers will actually start making sure that they're compatible with running via the OCI.conf. I don't think it'll be difficult. It's specifically made not to be. And, we've already tested a whole bunch of them inside of it, and they actually provide examples of several of them on the container guide. For the most part, I don't see why anything that supports an OCI container can't run. And in the worst case, you could always convert an existing image to an OCI container. In a lot of cases, it just means that you make a root directory and you throw the config.json with the required file entries. Right. Which container runtimes are recommended, and are there any known limitations, issues with them? We have documented examples of certain ones. They're listed here. And for HBCNG Singularity, you can replace that with Apptainer. These are the ones we have tested. Know they work. Limitations are long, but they're not specific to what Slurm's implementation. They're just inherited from the container runtime. So I'm not going to cover those here. So if the limitation applies to run C, it applies to calling run C and Slurm. There's no difference there. The other limitation is Slurm is explicitly unprivileged. If you want to run privileged, you have to do something like set UID or sudo. Make it very explicit. Slurm does not do it for you because everything runs as the user to make sure there's no ability for the users to do shenanigans. Would it be possible to spawn a container on cloud machines with Slurm to provide additional resources for HPC cluster on demand? Yes. Container support works the same on cloud nodes as it does on your local on-premises nodes. You just have to make sure that it's configured up and the file system's mounted correctly. Or in the case of cloud nodes, copied over beforehand, possibly using the generic burst buffer or something else along those lines. And it runs just the same as any other job. So there shouldn't be any issues or required extra understandings required. All right, so this is the end of my presentation. Please post bugs, issues, requests for enhancement on our site. We're very happy to get them. And I haven't seen any questions.
So now probably it's a good time to ask questions using voice functionality.
Sure. Does this require any plugins at compile time, or is it standardly by default included in 21.8?
Requires no plugins.
Okay.
It is included. You just got to make sure that you have the libjson -c included. It'll complain about and configure.
Okay. And there are new fields in the Slum database, so downgrading would be problematic and not compatible. So because if you do major upgrades in Slurm, so major version changes, it's always a bit problematic with the database.
Downgrading, we don't suggest or support. Upgrading, once it's in, it'll be maintained just as any other property in the database.
Okay, thanks.
So yeah, the idea is you can definitely upgrade safely and not lose your new container data.
About distributing the image, you said when you have 5,000 nodes, it could be a problem. Do you have any tests run so far on cluster that size? I mean, should it just be in a parallel file system, or?
So when you hit 5,000 nodes or so, you hit a lot of scaling issues. A lot of it depends on the file system you have. So let's say you have GPFS up with its read-only mode so that it won't do any form of locking. That'll be fine. If you do other ones like read-write, where it has to pull the lock out, it's going to go slow because you're having the same thundering herd problem as anywhere else. In that case, it's usually a lot easier just to copy it to a local swap or something like that on the nodes beforehand. Not exactly ideal, especially when you're scaling that size. You also got to make sure that the OCI runtime you're using isn't going to try to pull it from the internet. Because if you have 5,000 nodes with 64 tasks each trying to pull the same image from GitHub or somewhere, or Docker Hub, it's not going to go well. These are open areas of research, but right now you have to be aware of where your image is, which applies with everything else for the most part. Other solutions have, provided existing shared centralized image servers that can handle this kind of load. Something like Shifter has. Lots of sites will just have an image directory that will be able to handle this already because it's read-only, so you don't have to worry about the locks. Yeah, the Slurm part doesn't correct for this. I do suggest looking at the Lua Burst Buffer plugin because it, in the long term, I think can start handling this. But right now, there's absolutely no integration between the two.
Thanks.
All right, and I see a question from David. How does host Slurm interact with an Mpi job started inside of a container rather than starting Mpi outside of the container? Generally, Slurm doesn't talk to the Mpi layer. Do you mean PMI? With PMI, the socket can be there and still connect. In most cases, the user won't even notice this. In other cases, you may have to tell your container runtime to mount in the socket for the PMI. And then it'll work just as normal, as long as the job can start inside of the container. PMI is a stable standard, depending on which one you call. And so it won't matter if Slurm's talking to it from outside the container, inside the container, as long as the socket's there that it can read. As for starting the jobs, I would suggest using srun, or at the very least SSH with Slurm PAM adopt, so that the job is started by Slurm correctly, and it'll be sitting inside the container way one would expect. If your Mpi does SSH directly to the nodes and there's no PAM Slurm adopt, Slurm doesn't have any control over it at that point. Hopefully I answered your question. Are there any more? Well, I guess that's all the questions.
I guess so. Thank you very much once again for the presentation and being here.